Hello everyone. In this video, we are going to work out the IUPAC nomenclature of Trispiro compounds. As you might have guessed, these molecules contain 3 4-degree carbons or 3 spirocenters. One is here, another is here, and another is here. And therefore, our secondary prefix is going to be Trispiro. And then we are going to have 6 different numbers in the square bracket: x1, x2, x3, and then y1, y2, y3. On top of that, we are going to have 3 different numbers as superscripts. Those are the positions of the spirocenters, and then the parent chain. Okay. Now, it doesn't follow this format all the time, and sometimes we may have to follow this format like x1, x2, x3, and then the position of the spiro atom, first spiro atom appears on top of x3 instead of y1. So, we are going to work out 3 different examples. One of them related to the format, the first format, and then the 2 more examples I am going to show you that would be related to the second format. Okay. So, when we work out the names, things will be very clear. The key point to keep it in mind is, if the position of the spirocarbon that you are mentioning for the very first time is ambiguous, then you have to choose the second equation instead of the first one. So, let us first work out the IUPAC nomenclature of this compound first, which follows equation 1. Okay. So, we have 2, like basically 4 membered rings clubbed together. So, the terminal sides are even, and therefore we can start numbering from either side. Okay. So, let's start numbering from here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, total 13 carbon atoms are there, and therefore our parent chain is tridecane. Okay. So, the IUPAC name is Trispiro. Okay. No substituents are there. So, directly Trispiro, and then the value of x1. This is our value of x1, these 3 carbons 1, 2, 3, and then this is the value of x2, that is 1, value of x3 1, and then the value of y1 3, value of y2 1, value of y3 1. Okay. So, 3 dot 1 dot 1 dot 3 dot 1 dot 1, close the bracket, tridecane, because total 13 carbon atoms. And now we need to mention the positions of the spirocenters at the place of y1, y2, y3. Why? Because we need to distinguish these 3 with this 3. Okay. So, it starts at where this 3 starts, the second 3 starts 9, 10, 11. So, basically that spirocenter is 8. So, that you mention. Okay. And then we need to distinguish this one and this one. Okay. So, where is the other spirocarbon where the 12 is ending, it is ending at 6. Okay. And then this 13th carbon, it is ending at 4. So you need to mention that position also. So this basically this 864 are the positions of the spirocarbons that we are giving as superscript. So this is the correct IUPAC name for this. Now in the next example, it becomes clear to you that the very first spirocarbon that we are mentioning will become ambiguous, and that's why we need to shift one place in advance. What I am trying to say is that we have to put the superscript on top of x3 instead of y1. So let us look at the second example. Okay. For this molecule, we have basically 4 different rings. On the terminal, 3 different rings. So among them, 2 of them are 4 membered rings, one is a 5 membered ring. So we obviously need to start numbering from the 4 membered ring. But which 4 membered ring to choose? So if we choose this one, so then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if we choose this ring, then our spirocarbon positions are at 4, 6, 11. But if you choose it starting from here 1, 2, 3, then what will happen is the spirocarbon positions will be at 4, 6, 13, which we should not consider, because remember from the dispiro compounds what we learned is that the spirocarbons should have as low numbers as possible, and therefore the wave that we are numbering right now is correct. Okay, so we should not start from the start 1 from the 7th carbon. Okay, so that's the point I'm trying to emphasize here. So let's finish the numbering. So 11, and then 12, 13, 14, 15, 16, 17. So in total we have 17 carbon atoms in the parent chain, and therefore our parent chain is going to be a heptadecane. So Trispiro. And now you give the x1 value of x1, x2, x3, all those things. So the value of x1 is, we know the value of x1 is here 3, x2 is 1, x3 is again 3, so 3.1.3, and now we need to distinguish this 3 with this 3, but first let's finish it. So the value of y1 is 1, and then the value of y2 is 4, and then the value of y3 is 2. So 3.1.3 and then 1.4.2 heptadecane. Now we need to mention the superscripts, the position of the spirocenters. Now if we try to place it on top of the second one, I mean here, what will happen is it will become ambiguous, because where this one is coming, this one is basically starting at 6 and ending at 11. So that basically joins 2 different spirocarbons. Okay, so we should not do that. So the position becomes ambiguous. So the key point is, if the position of the spirocarbon that you are mentioning for the very first time is ambiguous, then you have to choose the second format. But so therefore if we mention at the 3 position to distinguish between the first 3 compared to the second 3, then it is starting at 6. So basically the 7, 8, 9 is what our x3 value is, which is 3. So on top of that you write the 6. Okay, so that it becomes unambiguous. Leave the y1, and then C y2. y2 is again unambiguous. 12, 13, 14, 15. So those 4 carbon atoms are joined at 11. So you mention that. On top of 4, you mention that spirospenter. And then the 16, 17, it is ending at 4. Now, because we mentioned the 2 spiro centers very correctly, therefore it has to, the 16, 17 has to end at 4. Okay. So that is clear. So this is the correct IUPAC name for this. On the contrary, if you give this name, like thinking that if you, I will just choose the first format, then the structure won't be generated. Okay. This is wrong. Okay, because the position here is ambiguous. Therefore, it is wrong. Okay. So you can also cross check this yourself with the OPSIN. There's a popular website for IUPAC from the University of Cambridge, Department of Molecular Informatics. It's an open parser for IUPAC name generation. So you can give both the names. The first one will generate the structure and the second one won't. And by the way, there is no provision to write superscript, so you have to write it as 36.1.411.24. That's the way you have to write it. So you can cross check that yourself. Okay. So let's move on to the third example. So here we have 2 3-membered rings and then 1 5-membered ring on the terminal side. So obviously we are going to choose the 3-membered ring. So let us choose this one. So 1, 2, 3, that's our first spirocarbon position, and then 4, second spirocarbon position. Okay. So in this case, these 2 spirocarbons are directly attached to each other. Okay. Then 5, 6, 7, 8, that's the third spiro center, 9, 10, 11, 12, 13, total 13 carbons. So our parent chain is going to be called as tridecane. So trispiro, and now if you want to work out the name yourself, I suggest that you pause the video, work out the name yourself, and then just come back and see what you are getting. Okay, trispiro, but I'm just going to continue like this. Okay, trispiro, then the value of x1. So that's our value of x1. x1 is 2. What is the value of x2 here? Is it 1 or 2? No, the value of x2 here is, the value of x2 here is 0. Why? Because it is directly attached. These 2 spiro centers are directly attached. Therefore, the value of x2 is 0 here. Okay, x2 equal to 0 in this case. Okay, that we have to mention. And then the value of x3 is these 2 carbons. x3 is also 2, and then this is y1, that is 1, and then y2, these 4 carbons, that is 4, and then finally y3, that is 1. Okay, tridecane. Now in this case too, if you mention the first spiro center on top of this 1 at the place of y1, then it becomes ambiguous, and therefore we need to mention it here. Okay, at the position where the x3 is mentioned. So x3 is starting at 4 and then ending at 4. So that's the spirocenter. Basically this 5 and 6 carbons 5 and 6 are attached to the fourth carbon, which is a spirocenter. So write that one as a superscript, leave out this one, and then mention the B value on top of 4. So that is basically 8, because this is the spirocenter, okay, that represents the value of Y2, and then 13 is ending at 3, okay. So you mention that. So that's the correct IUPAC name for this. So the point that you need to always keep it in mind is the position of the spirocarbon that you are mentioning for the very first time should be unambiguous, okay. That's the key point that you need to keep it in mind in the case of trispiro compounds. So if you do like this video, consider subscribing it to Chem Media, and thank you.